How's it going, guys? And in this video we are going to be talking about binary trees in Python. We're going to be introducing the subject as well as walking through a demo in which our goal is going to be figuring out what is the sum of every node's value in this tree. And so if you know stuff about linked lists, binary trees are very similar. The main difference between a linked list and a binary tree in Python is that in a binary tree, each of your nodes can have 0, 1, or 2 child nodes. And so in a linked list, your node can only have 0 or 1 child node. But in these binary trees, you can now have these forks like we're seeing here in this little picture, where you can have a left and a right, or just a left or just a right, or none. And so that is the key thing to make note of. And in addition to that, these binary trees have properties to them that we need to follow when we're creating these things. And the main one is that the left node, so when you're defining these nodes, each node will have a left child and a right child. The left child must have a value that is less than the right child's value. And then in addition to that, the left child's value must be less than that of the parent's value. So I know it's a little bit complicated, but basically what it means is that right here at our root has a value of 13. Therefore, the left child, node 2, must have a value of less than 13 or 12. What is not acceptable in these binary trees is something like the following, where if we were to say make node 2's value, call it, let me make it the size not too enormous here. If we were to make this thing's value something like 14, that is incorrect because 14 is greater than 13, and so this tree is incorrect. So even though 14 is less than 34, it violates the rule in that the parent's node has a smaller value than the left node. So that is wrong. Do not do this. The correct thing to do here is to make sure that you are constructing these binary trees correctly. And so the correct thing to use here is something like 12 or anything less than 13. And we're sticking with integers right now. And so the other thing here is that I just tried to make it pretty explicit in these charts. So like for 34, for node 3, it has a value of 34. If you had a child node of 3 with a value of 89, does that have to be the left node or the right node? And the answer is that that has to be the right node because 89 is greater than 34. So you cannot make node 6 the left node of node 3 because that would violate our rule. So node 6 has to be the right node of node 3 in this picture. And so with that out of the way, we will now look at actually coding this up in Python. So I'm going to minimize this window and we're going to pull up a PyCharm terminal. And so in PyCharm here, the first thing we're going to do is define a class to actually persist how we're going to construct node objects. And so I'm going to create the constructor, and each of our nodes is going to have a value. So let's say val, and this will be whatever value is provided when we're constructing our node. And then each node will have a left node and or a right node and or none. But what I will do in Python is I'll say these will default to none if no information is provided. So I'll say self.left gets left and self.right gets right, and these are just pointers in memory to the other objects, the other node objects that make up the left node and the right node for a particular node. And so that's all you need to do to declare your node class. And now what we're going to do is create a class to persist how we can create a binary tree example. And so with these binary trees, I will have another constructor, and before I forget, I will need to instantiate an object of my binary tree so that we can actually run these classes. We can actually create objects of these classes. And so what we're going to do in the very first thing here is I'm going to declare and define the nodes of the tree. And so I'm going to create a root node. So this will be derived from the node class, and I will give this thing a value of what we had in our original picture, which was 13. And then I will declare a node called n2 to also be derived from the node class, and it will have a value of 12. And we're going to do this following for node 3, 4, 5, and 6. And so with node 3 is going to have a value of 34, just sticking with our example in the beginning. Node 4 had a value of 7, and node 5 will have a value of 15, and then node 6 is going to have a value of 89. And so we've now declared and defined our nodes. Now we need to define the relationship between nodes. And so what we already said in our picture visually is that the root node, self.root.left, is self.node2, and then self.root.right is going to be equivalent to node 3. And then for and I have to use the self because we're referring to the objects. And then self.n2.left is node 4, just referencing the picture. And then self.node2.right is going to be self.node5. And then finally we had self.node3 and .right must be the node 6 object that we created. So now we've defined all these relationships. What I'm going to do here is put in a little print statement just to make sure that we don't get any errors when we instantiate our binary tree object in Python. So I'm going to run this in a debug mode. And we're looking good, so that's great. And so now what I'm going to be doing is creating a class to actually sum up all of the values of these nodes that make up our tree. So def calc tree sum, and this will take in a node, and we're going to iterate through all these nodes. I'm going to pause the video here if you guys want to take on a coding challenge and try to do this on your own. The first hint I will give you is that we're going to be using recursion, so you can pause the video right here, and when you come back I'll walk through my implementation, and now we'll resume. So we will make use of recursion, and so what I'm going to say here is we're going to be doing the following. So the base case for our recursive function will be if node is none, we will return 0. So basically if we have no nodes in our tree, or if this node has no other child nodes, no left or right node, then we're going to say that there's no value of this node. And then else, and this is going to be our recursive case. Sorry, I can't spell recursive case. We're going to say return node.value plus, and now we're going to make use of the recursion, self.calcTreeSum node.left. So we're going to sum up the current node's value as well as the value of its child on the left and its value of the child on the right. So self.calcTreeSum node.right. And so that is what our calcTreeSum method is going to look like. And now within the constructor, I will just call this actual method. So we will do the following. So I will say print the sum of all nodes within this tree is self.calcTreeSum node, and I will feed this the root node, self.root. And I'm also going to write down that I'm making an assumption here. We are assuming that we are given the root node of the tree as a starting point. And so from there, I will put in another little print statement just so I can have a break in my code. And we're going to run this. And if we look at our console, we should see that the sum of all nodes within our tree is 170. So I'll let you guys check that and confirm. But this is a quick introduction to how binary trees work, how we can define their values and the relationships, as well as write a method to actually iterate through this tree to tell us if or what the value of our sum is. So hope this video helps. Thank you for watching, and let me know if you have any questions. Take care.